All right, let's take a look at 5.1 and 5.2, exponential and logarithmic functions and their graphs, and go through a few examples of those graphs. So just a reminder, an exponential function is one where the base is a regular integer and the power is a variable. So something like y equals 2 to the x. All right, so take a quick look just to evaluate something like this. If we have f of x equals 3 to the x, then of 2 equals 3 squared, which is 9. All right, so let's go ahead and for our graph. So again, we want to go ahead and do the point that corresponds with x is 0 and x is 1. We're actually not going to worry about that. And then we're going to put in the x-axis with the horizontal asymptote. That might be shifted up or down. Let's remember how we do this. So first one, we have a t-table. We want to make the power equal to 0, equal to 1. So in this case, it's just x equals 0 and x equals 1. 5 to the 0 is 1. 5 to the first is 5. Our asymptote is y equals 0 because there's no shifting. There's not a plus or minus. It's plus 0 off to the side. So asymptote at y equals 0, comma 1, 1, comma 5. Nice smooth curve. Exponential graph. Try it again for a fraction, 2 over 5. So again, we're going to say 0 and 1. So anything to the 0 power is 1. 2/5 to the first is 2/5. So this is going to be 0, comma 1. And again, y equals 0 is our asymptote. We'll have 1, comma 2/5, which is 0.4. So this is going to be coming down like that. Just connect the 2 points with the curve. Okay, so we can do the same thing here. 2 to the x plus minus 1. Let's just do the first one here. So we're going to have our t-table. In this case, we want this to turn into 0. So x minus 1 equals 0. X equals positive 1. We want this to 1. So if we add 1 to both sides, we're going to have a 2. So 2 to the 1 minus 1 is 0. So this is 2 to the 0, which is just 1. And 2 to the 2 minus 1 is to the first is 2. Asymptote y equals 0. 1, comma 1. 2, comma 2, asymptote with the graph. All right, so on this domain, it's going to be all real numbers. So you can plug in any for x. The range, that's what y values could we use. So this we're going to say y has to be greater than 0. Because y equals 0 is a line we can't touch. We have to be above that line. All right, how about a shift? 3 to the x plus 1 minus 2. Figure out our x's and our y's. For our x, we want this equals 0, this equal 1. So x equals negative 1, x equals 0. If we have 3 to the negative 1 plus 1, that's 3 to the 0 power, which is 1. And then we subtract the 2 minus 2, we get negative 1. And then for the next one, we would have 3 to the 0 plus 1, which is 3 to the first, which is just 3. And then 3 minus 2 is 1. Asymptote y equals, thing hanging it out by itself, negative 2. Let's graph it. 1, 2. Negative 1, negative 1. And 0, positive 1. Looks like that. Domain, all real. Range, y is greater than negative 2. Okay, natural base E, we talked about this. E is approximately equal to 2.71828. As long as you remember 2.7, that's enough. Okay, so let's go ahead and graph this. So on this, we're going to say x equals 0 and x equals 1/2 again, because we want 2x equals 0 and 2x equals 1. So if we plug in 0, 3 plus e to the 0, that's 3 plus 1, which is 4. And then we're going to say 3 plus e to the first, which is 3 plus about 2.7. So we're going to say about 5.7. Our asymptote is y equals 3. So 2, 3. And so we'll say 0, 4. And we'll say 1/2, which is right in here, up to 5.7, right about here. There we go. Okay, let's talk about logarithmic graphs. So remember that a log is just the flip of an exponent. So if we say b to the, let's just do it with numbers. If we have 2 cubed equals 8, then log base 2 of 8 equals 3. Okay, so we have this, again, just rearranging them. So if you want to pause the video and check those out, just to make sure you remember, go ahead and do that. Okay, and it works both ways. So again, log base 2 of 16, 4. In a logarithm, we're solving for the power, solving for the power. All right, finding the exact value, 3 to what power gets me 81? The answer is 4. So on this one, 169 to what power is 13? It's 13. The square root of 169 is 13, so this would be 1/2 is your power. And then on this one, 5 to what power gets me to 1/5? You need to flip it over, so that means -1 is your power. All right, so we can use a calculator on this one as well. So we did this in class. I'm going to keep moving past this. We're going to talk about graphing. So remember that logarithmic graphs are the inverse of exponential graphs. So if we have a 0, 1, we have 1, 0. Put your x's and your y's. So let's take a look at some examples here. So we want to make the exponent equal to 1, a base, and 0 for the asymptote. So we're going to say x minus 4 equals 1. X minus 4 equals, in this case, b. Right, so let's pick one with an actual number here. All right, we're going to go ahead and do this one. So we're going to say x minus 3 equals 1. X minus 3 equals the base 2, and x minus 3 0 for the asymptote. So for our t-table, we're doing problem A here. If we add 3, we'll get 4 for x. If we add 3, we'll get 5 for x. And our asymptote is going to be x equals 3. Let's plug this in. Log base 2 of 4 minus 3 is log base 2 of 1. That is 0, because 2 to the 0 power equals 1. That's your y. All right, if we do log base 2 of 5 minus 3, we get log base 2 of 2, and that is 1, because 2 to the first equals 2. Yep, that. So let's graph it. 4, 0, 5, 1. Asymptote is x equals 3. Start low, vertical, flatten out. All right, domain. X is greater than 3. Range, y is all real numbers. All right, we'll do one more here. So on this one, we're going to say x minus 3 equals 1. X minus 3 equals the base, which is 2. X minus 3 equals 0. So for our t-table, again, we're going to have 4 and 5 and 3. And for our y values, we're going to say negative log base 2 of 4 minus 3 is negative log 2 of 1, which is negative 2 to the 0 with 1, so negative 0, which is still just 0. For 5, we're going to have negative log base 2 of 5 minus 3, which is negative log base 2 of 2, which is negative 1, because log base 2 of 2 turns into 1. So we have negative 1 here. Let's graph it. 1, 2, 3. Okay. On this one, we have 4, 0. We have 5, negative 1. Graph is going down. Why does that happen? Because there's a negative in front. Remember, negative x squared looks like that, right? It would be flipped over. All right, that'll do it. We will see you in class.